Hello, welcome back to our discussions of MySQL. Today we're going to take a look at null values in the database and how null values are dealt with in the select statement, how they behave. But first, let's take a look at where nulls come from in our data. So null is defined in SQL a little differently than it's defined in a language like Java. In a language like Java, null means it's an object reference that refers to no object. In SQL, null means unknown, not there, outside of the system. It's a subtle distinction, but sometimes important. So let's look at our create table statement, and this is where our customer's table is defined. Its columns, again, are defined first, and then the data comes next, and those become the rows. And the way the script works, it creates a table, and then as soon as it can, it has the insert data into that table. And we'll look into all of the syntax in later lectures. For now, this is the creation of the customer number. We see it's an integer and defined as not null. So once you define the column's name and the column's data type, everything else about it is called a constraint. This, in fact, is a column level constraint, not null. Customer number has to be there. It has to be populated. So if you tried to insert a new row into the customer's table and you didn't specify the customer number, that row would be rejected in its entirety, and the database would not change. It requires the customer number to be there. So later on, when you update the customer table, you can't blank out the customer number with a null. The database will not allow it. This is a data constraint, a rule applied to that particular column. So null is the default, so you have to say not null if that's what you want. And in my opinion, not null, it should be the default case for all data columns in the database, not null. There's rare occasions where you want to express null. And there's a few here in this example here. In fact, wherever it says not null, it defaults to null. So default, null. So this means that address line 2 doesn't have to be there when this customer data is inserted. Address line 1 has to be there, but address line 2 is optional. Doesn't have to be default, doesn't have to be there, and when it's not there, it defaults to a null value. And that's the way this database is described here. You could do something alternative here. For example, address line 2 default empty string by putting two quotes next to each other, default to an empty string, but they didn't do that in our database design here. So it's either not allowing nulls at all or defaulting to nulls. So when we do a select statement on the customer's table and see the result in the actual data, you'll see that customer name number is always populated, never null. It's invalid. It's not right. It cannot exist. That is, the database will reject any row and any update to the table that results in one of these not null columns being defined as a null. But the ones that aren't defined that way, for example, address line 2, there we see null values in here and in the state. So we have some countries that our business does business in don't have the concept of states, and you'll see that as a null value here in the result set. Also, you'll see that some customers don't have sales representatives. So we'll visit how to deal with null values and how null values work in the select statement next. For now, keep in mind how our introductory into how these tables are created by their columns, by their data types. Everything else is a constraint. Okay, I have several examples here of using null values in the context of a select statement, namely in this context of a where clause. They come up other places too, though, dealing with null values. Special unknown values, remember. So I'll run all my queries. I have several of them. And we'll start with 43, which is, again, selecting all the rows, all the columns from the customer tables so we can get an idea of what's here. And we saw how the customer's table was defined, so we now understand why these null values can appear here. Address line 2 is not specified. The database allows that. And remember that address line 1 was defined as not null, so therefore you'll always see that. The row cannot exist that has a null value in that particular column, or in the customer number, or several other columns here. But the address line 2 can be null, and the state can be null. So let's take a look at this. This is a business problem. Give me a list of customers that have no sales rep. Sales rep can be null. So give me that. So here's our first first query, and it has no results. Yet we can look over here and see, well, we have some results here, right? And the problem here is this equality operator. Since, and this is getting into the nitty-gritty of the difference between null in SQL and the difference with null in a language like Java. Null is unknown in SQL. So you logically can't say, is it equal to unknown? Because you're saying unknown here is equal to unknown here. We don't know it, so we can't say it's equal to it. Let's look at this select statement here. Is 2 plus 2 equal to 4? Is 2 plus 2 equal to 5? Is null equal to null? And here we see 2 plus 2, yes, equal to 4. That 1 indicates that. 0 indicates that it's not equal to 5, but null says, I don't know if null is equal to null. It's unknown. So there's a special operator for null, the is operator, the special logical operator for null to get around that logic problem. So here I have null is null rather than using the equality sign. So you have to use the keyword is in order to look explicitly for null values. So null is equal to null, still unknown, but null is null, yes, that's true. Okay, now we can update our query with a bug fix. Select all customers or all columns from customers database where the sales rep is null. And this is a list of customers that have no sales rep. And you can see sales rep is null in all cases. Give me a list of customers that have a sales rep. You can do is not null. And here's our customers that have sales rep set to not null. It comes up with distinct also. So let's take another look here. Count star, count state, and as we talked about earlier when we were talking about the aggregate functions, count star counts all the rows. Count state will count all the states that it finds. However, state in this table can be null. Therefore, you can have fewer states counted than you have total rows. If you put a not null column in count, it will always be equal to the number of rows because it has to be populated. For example, if we did count of customer number, it would come up with the same results as count star. So count distinct state, this will say the distinct number of states in the number of states, that's 18. Already eliminated the null values though, so it's the count of states that are set. So total rows, total number of states, total numbers of distinct states. And remember, when you're looking for null values, use the is keyword. If you're looking for not nulls, you do is not null. All right, that's the definition and use of null values in SQL.